The objective of the project was to calibrate a photocell sensor by methods of static and dynamic procedure. A photoresistor is composed of a cadmium sulfide material in which the electrons are bound to the crystal lattice. As light is emitted, the electrons break free from the crystal lattice and can flow freely through the material of the photoresistor. In our experimental setup, we used an LED that directly output light to a photoresistor. Between our multiple breadboards and lux meter probe, we were able to statically and dynamically calibrate the photoresistor. In our static calibration, light intensity was raised from 0 to 0.6 foot candle, and the voltage output was recorded every 0.1 foot candle. In our dynamic calibration, the LED was flashed with its maximum light output and was held at this maximum light until the photoresistor had reached a steady state value. In our design stage uncertainty, our two components were our light meter and the DACA system. In our experimental uncertainty, we had linearity and zero drift errors. Our total uncertainty was then calculated. In our static calibration, we achieved the results of a decreasing linear trend between voltage and light intensity. This data was then fit with a linear regression function to achieve its static sensitivity. For the results of our dynamic calibration, we observed a first-order response between voltage and time. To find the time constants, our first method used was the 63.2% rule, which achieved a time constant of 0.115 seconds. By our second method of polyfit and z-plot analysis, we found that there was two time constants in the system. Time constant 1, 0.0146 seconds, and time constant 2, 0.1485 seconds. In our summary of results, in our static calibration, we observed a decreasing linear relationship between voltage output and light intensity, and when fit with a linear regression function, the static sensitivity was achieved as negative 96.158 volts per lumen. In our dynamic calibration, a first-order response was observed, however, it contained two time constants by methods of z-plot and polyfit analysis.